With more than 1,000 punts over a 16-year NFL career, Craig Hendrick knows down to his toes the secret of a perfect punt.
When you make contact with that ball, it's almost a feeling that you don't feel the ball on your foot. It's almost like you're swinging a leg at air when the ball comes off of there perfectly.
Elite kickers like Hendrick have been known to launch a football 120 feet in the air at speeds of up to 90 miles per hour. These powerful punts are a perfect example of projectile motion. And the arc the ball makes as it slices through the air is something that has been studied by scientists for centuries, all the way back to Galileo Galilei, one of the great thinkers of the Renaissance.
He's one of the first people in Western science to realize that the shape of that curve is something the mathematicians had been talking about for a couple of thousand years. It's called a parabola.
To help us understand projectile motion and parabolas, we asked Hendrick to perform his craft in front of a super high-speed camera called a phantom cam. It all begins with the drop.
And action.
In the ideal drop, the ball has to stay level, or with the nose or the front of the ball slightly up. At the moment of impact of the ball, our leg will actually snap and actually straighten out at that moment, and that's the exact moment that you want to make contact with the ball.
And up it goes, following a path and the laws of gravity.
Once a punter kicks a football, it becomes what we call a projectile. And it follows a path that we would also call a parabolic arc or a parabola.
As the football flies through the air in the shape of a parabola, there are two main components of velocity affecting the ball.
It has a horizontal component, the speed it's traveling along the ground, and a vertical component, the speed it's moving vertically.
These two velocity components, the vertical and the horizontal, can be represented as vectors.
A vector is basically an arrow in 2 dimensions that describes some kind of physical quantity.
In this case, vectors show the physical quantities of speed and direction. The greater the speed, the longer the velocity vector. As gravity tries to slow the ball down, the vertical velocity vector gets smaller.
Gravity is acting on it from the instant that it leaves the player's foot, but the effect of gravity is demonstrated by the fact that the speed of the ball is decreasing.
Gravity eventually causes the football to stop rising and reach the top point of its trajectory.
When it's at that high point, something very curious goes on. It has no up and down speed at all. And so the up and down speed of a ball at its maximum point of arc is 0.
Our goal in punting is to get the ball to hang in the air, to be in the air as long as possible.
And then it begins to come down, and the speed goes from 0, and then it comes back down really fast.
Gravity pulls the ball back down to Earth. As it gains more speed, the vertical velocity vector now points downward.
When it starts to come back down to the ground, the vertical component of velocity is in the opposite direction, and the horizontal component is still the same.
And down it goes until it reaches its mark.
It was always a great feeling to get as a punter to watch that ball go in the air knowing that you had hit it perfectly.
Parabolas come in all shapes and sizes, but it takes NFL punters like Craig Hendrick to turn science into an art form.